Hi, this is Bill Vales. I'm here at Littleton Middle School, and this is another edition of Fun with Science. And I'm here with Deanna Clark. Deanna, how are you?
I'm good. How are you doing?
I'm doing good. And you're with the Littleton Robotics, correct?
Yes, I'm the team manager for Littleton Robotics.
Okay, can you tell us something about Littleton Robotics?
Yeah, so Littleton Robotics was founded last June, and we comprise of 2 robotics teams, one at the high school level and another at the middle school level. So today we're here with our middle school teams. We have 3 of them, and they participate in what's called First LEGO League, or FLL. And basically for FLL, they have to do 2 main tasks. They have to build an autonomous robot to complete certain missions, and then they have to complete a research project on the game theme. And this year, the game theme is all about water and wastewater. So our students are in the middle of their season right now. The robots are underway, the projects are underway, and they have competitions coming up in November and December.
And where are the competitions held, and with who are they held?
So we have 2 practice competitions and then an official competition in December. So the first practice competition is actually being hosted by our high school team, and it's going to be right here at Littleton Middle School. It's basically an opportunity for the teams to practice their interviews that they'll have to go into at the competition event. So they have a robot interview, they have a project interview, and they have an interview about the FLL core values, or basically how they work together as a team. So that's going to be on October 28th here. The second competition is all about robot matches, and that's going to be held at Algonquin High School on November 4th, and that's just practice time for the teams to go out on the field and run their robots for the 2.5-minute matches. The last competition is going to be held on December 2nd. We're still waiting to hear back where we're going to be, but we're either going to be at Neshoba Tech for that one or WPI, and that's an official competition with both interviews and robot matches.
I see. How wide is this robot competition? Does it span across the nation?
Yes, so First LEGO League is a worldwide competition. So there are teams from all different countries. We compete in the Massachusetts region, so we just compete against Massachusetts teams. But if you go to World Festival, there's teams from literally all over the world. There's about 35,000 FLL teams now. Wow,
that's really impressive. I know you have a very well put together website that has a calendar on it that'll show these events, and we'll publish that on the program so people can see that and reference the activities of the club.
Yeah, that'd be great. We're really busy and we're always around town and trying to do new things, so definitely that'd be great.
Okay, great. Well, let's venture on down and see what's up.
Sounds good.
Okay. Okay, Deanna, where are we now?
So this is the field for this year for First LEGO League. So the teams have to do a bunch of different missions surrounding the objects on this field. And if you look closely, you'll see that all the different missions relate to water and wastewater.
Okay, now the field, is this, everyone in this competition will use the same field?
Yes, everyone uses this field this year.
Okay, so I do see things related to water throughout, so go ahead and...
Sure. Yeah, so there's a bunch of different missions. For example, one of the missions is you can take this pump edition. It starts right here. Your robot can come and push it back and then insert it into the other pump, which is stationary on the field. Other things you can do on the field, over here, you kind of see this mission, and this mission is the object is to move this lever and make the rain fall out. Another pretty cool mission over here is if you flush the toilet. The toilet fell over, but you'll see that your waste came out of the wastewater treatment plant and your clean water came out the other side, which is pretty cool.
Now you say the robot's going to make these things. Where's the robot?
So this is an example of one of our team's robots. So the kids write the code in advance, and then you launch it from this white space here. So the kids will select a program, it'll come out, it'll autonomously perform one of these missions. So for example, the robot could come from here, drive out like this, push the pump in, turn around and then come up and bump the pump into the addition. And then it does that all by itself and then returns back to base after each different mission.
I see. Now, you mentioned write the code. So this is a programmable, it's a computer?
Yes.
Okay,
Yes.
and what sort of computer language is being used?
So there's a language that's built just for this block. It's called EV3 Mindstorms, and that's the programming language. It's basically a LabVIEW based image programming, so it's drag and drop. The students make it like that, but all the background is running, regular code. It's just a really easy way for them to learn and visualize it in the middle school years.
Sure. And what platforms does that code run on? Windows or Mac or both?
Runs on both, yeah. So it runs on Windows, Mac. There's also an app for Chromebook and iPad, which is pretty cool.
Wow, neat. And does the club provide the computers for the kids, or do they have their own computers?
We have some computers that we bring in for the students to use, and we also ask if kids have computers that they can use, they bring those in because it's good for every kid to have one. We're a community-based organization governed by a nonprofit organization, so we're not school funded, so we raise all our own money through grants and corporate sponsorships, and we even had a car wash fundraiser at the beginning of the season, so we work really hard. And obviously, a lot of computers would be crazy budget. So we have a few, though.
So I see a lot of branding for Lego here. So Lego certainly has their hand in this. And what do they provide for you?
So Lego is just a sponsor of First Lego League, so they work directly with First, which is this program right here. So that's basically the governing organization for all these programs, and it actually stands for Inspiration and Recognition of Science and Technology. So that's kind of the mission of the program. So they partner with Lego to develop these game sets in these fields for the teams to use each year.
I had looked at your website, and First was developed by some inventor.
Yes.
Who was that?
Dean Kamen is the founder of First.
Okay, and what's he notable for?
Lots of different things. The most notable, I think, is the Segway, but he also designed this, actually. It's called a Slingshot, and it's a water filter, and it's a part of the game this year, which is pretty cool. But he is a crazy inventor. He's done a lot of really notable things, but those are two of the biggest.
Okay, I recall the Segway.
Yes.
Yeah, and there was a video of him on that. So.
Yes.
We're going to walk around and see what the students are doing. This gives us a good overview of this, so
Awesome.
Let's walk around.
Sounds good.
Okay, I'm here at a field, or what do we call this layout?
A mission field.
A mission field, and I'm here talking to
Anne.
Anne. Okay. Anne, I see you have a MacBook Air here, and what's going on here?
So we're doing programming for our robot on the MacBook, and it's using a software or program called Lego Mindstorms EV3. And there's blocks that we can input numbers into, and it'll make the robot run the mission.
Okay, and I can see this is a very graphical interface. Now, are you the programmer, or does everyone do programming?
Everybody can program.
Everyone does. I should ask, and your name?
Adriana.
Adriana, and yours?
Nathan?
Nathan. How are all you? So, do all of you do programming? You do. Okay. Boy, you learn programming pretty young. So, how many programming languages do you know?
Just this one.
Okay.
Yeah, just this.
Okay. Has this piqued your interest to want to learn more about programming languages?
Yeah, because before I used this, I just thought every programming was very complicated, but this made it seem easier.
Sure. I mean, you can relate to pictures and move them around and connect inputs to outputs and that sort of thing. Well, let's do something.
So the programming on here connects to the robot by Bluetooth.
Okay, Bluetooth.
So every time we update something in the program here, we can just download it and then it will run on the robot.
Okay. Now, a lot of people think Bluetooth is only used for telephones.
Yeah. And then that's the end.
Okay, so what you have there is you have certain tasks that you have to complete, correct?
Yes.
And you're doing that incrementally. You've started on one task. And what is the task that you're trying to accomplish here?
Do you want to say it?
So we're trying to, with our robot, push this down so that that toilet thing can flush and push the things out.
I see. And each time you do a task, do you have to start at a particular part on this board?
No, we can just start wherever, like depending on the task, it just starts where you left off.
So,
I see, but when you started off here, would you always start in this area here?
So for everyone, we have to start in the base. But if you want to do multiple missions on one run, then you can just program the robot to do a few missions while it's out in the field. But it always has to start and come back to base.
I see. So you start here, go down there, do a task, and then if you have another task to do, you would go from that position there
Yes.
to there. Okay. So who did the programming for this?
It was other people in our team who are currently working on something else.
Okay. So everyone does different things on
Yeah,
this.
so we take turns on doing our project and the robot programming so that everyone gets fair share of working on everything.
I see. Are there some jobs that are better than others?
Well, some are more fun, or some might be harder or more boring, but they're all pretty fun.
Okay. What are the boring ones?
Well, the boring ones might be like gathering information, stuff like that.
So that's like the design. Yeah, so the fun stuff is the implementing, right? Doing the programming, testing,
Yeah.
running the robot into the walls, things like that.
Yeah.
Okay. All right, well, we're going to let you go do some more programming. Thank you all very much.
Welcome.
Okay, I'm here at a field, and who am I here with? First name?
Hunter!
Hunter.
Elise.
Alish. Did I say that right?
Elise.
Elise. So what are you doing here?
We're basically going, we have our robot programmed to run the mission right there, that one, and pushing the pipe into that.
Okay, so you have a mission here that you're
Yeah.
trying to accomplish, and we were just joined by
Jonah.
Jonah. Okay, what is this device?
It's basically the robot has to push this. Why does it? It has to push it shut. Like it'll end up like that.
Okay. So who wrote the code for this?
The code uses other code in a way.
I see.
My blocks, we call them.
Okay.
So that does things like turning and going forward.
I see.
I wrote most of those, but then we worked together on putting them together in order to accomplish the task.
I see. So you have a library of primitive functions that other tasks can use.
Yes, that's correct.
Is this a test run, or have you done it before?
We've done it before, but it may or may not properly work.
Well, let's give it a shot. In this position here is your start position?
Yeah, or
Yep.
base.
Base. Okay. I'd say, based on your description of what you were supposed to do, that was a success. What would you say?
It went good. Did you set it to just do that, or?
Yes, so that was a demo mode. That wasn't the full mission.
Okay, so you're going to run the full mission now?
We're trying to.
Okay.
We're having connection problems to the robot.
Okay. That's typical of anything in engineering.
Yes, I would say so.
Yeah, nothing works right the first time, or the second time, or the third time. Okay, we're going to have another run here. Oh, so you were having a Bluetooth connection problem?
Yes, so now we're using a wired connection, which is much more reliable.
Okay. But you need a long wire.
Not necessarily. If it's very close by the robot, you don't need that.
Okay, that's true. Let her rip. Did you just download the software to that?
I
Is that-
downloaded the program.
The
and then
program?
the software that's already on the brick will run the program.
Okay.
This extended version is even less reliable than the version we just saw. So this doesn't seem to be quite right.
Not quite right because it didn't return to base?
Not quite right, because that whole sequence it started doing, manipulating its arm, was supposed to happen later in a farther area from the filter.
I see.
We seem to still have traces of that demo mode,
I
where
see.
it doesn't go far enough.
I see. Now, when you're moving on this field, is this arranged like a Cartesian coordinate system? You know, X and Y positions?
It's arranged, and there's a compass there, as north, south, east, west.
Yes.
The robot itself can't read an X or a Y position.
Mm-hmm.
It has to do everything based on where it is now,
Yes.
which is one of the biggest challenges of FLL.
I see. So when it has to move based on where it is now, how do you control whether it goes 6 inches or 8 inches or 12 inches?
Distances are mostly controlled by movement of the wheels, so it can measure when a wheel turns how far it's gone, and that's how it measures distance. If it's doing direction, it has a sensor, an accelerometer, that gives it a direction based on how you start it.
I see, and the direction is based on the compass coordinates?
Ideally, yes, it would be, but wherever you happen to start the program is where 0 is. So if you start it 2 degrees off,
Yes.
then everything is 2 degrees off from where you would like it to be.
I see, I see. And where is 0?
0 is wherever you start it. So if
Wherever
I
you
start
start
it
it.
here, that's 0.
Okay, all right. You have another test run you're doing, or do you have to go back to the drawing board and think about things?
We may need to make more adjustments in order to have it not repeat what it just did.
Okay, all right. Well, this is engineering, very iterative. Try something, doesn't quite work. Try it again, doesn't quite work, and you'll get it right. I'm confident. You got a lot of smart people here. Okay, great. Well, I've just entered I think a design review session here that's going on. And who do we have here?
I'm Joseph.
Joseph?
Arav.
Arif?
I'm Chris.
Chris?
I'm Shruti.
Jonathan.
Okay. How are you all? So, what are you doing here? We have 2 computers here.
Okay, so right now, we thought like the water at our school, as you can see from the water fountains over there, it's not very good. It's very high, and like the temperature, not many kids drink off it. Like something's growing over there, if you see. So we're trying to get better water fountains at our school that are cleaner and more effective. So what we've been doing, we're creating a project to see like what the water is going to be. So right now during school, I'm going through homerooms and I'm giving them surveys of what they think of the water fountains right now. And from what I've seen so far from just like random people is that like if they rate it on a 1 to 10 basis, -1.
Wow. So you're collecting data
Yes.
You're collecting data, and then what are you going to do with that data once you've collected it?
So we're gonna show it to the principal, and like we're going to a PTA meeting on November 1st, and they're gonna see like how much they could pay for it, and if this all ends out well, you might see a new water fountain at our school sometime.
Wow. What do you think of the water?
Well, personally, I don't think it's very refreshing,
Okay.
and sometimes it can't be that clean, and there are certain types of bacteria that can make you sick in water,
Sure.
like maybe digestion problems.
Sure, absolutely. Will you be testing the water? Will the water be tested?
Yeah, they had a plan to bring in some water testing, like little kits that you can buy online, and testing the water from a few of the water fountains to see whether or not they found the bacteria that they researched, such as E. coli and Shigella, which can cause dysentery and urinary tract infections.
Wow. Okay. Have you talked at all to the Littleton Water Company about what they think about the water?
So far we haven't, but that could be one of our future plans.
Yeah, I think that would be, they'd be very interested in knowing the quality of the water. What do you think of the water?
Well, I've been here for 3 years, and it's very warm.
Very warm.
Yeah.
I see. And is it warm at any time of the year? Is it warm?
All around the year.
All around. Wow. So how long have you been collecting data?
We just started this Tuesday because we've had like surveys and stuff. I'm going with a friend right now, but he's not here, but texting me at the moment. Right now we just went to a lot of homerooms right now, and a lot of kids have been asking me about negative numbers. It's true. So
Wow.
it's looking good for us right now.
Yeah. But not looking good for the water.
No.
Okay. Are you getting support from people in this project?
We've talked to the principal a lot, and she's more towards it. And she said last year it was on her list for the PTA, but it's more down because of last year. So because of us, this might speed up the process or something like that.
Okay. So who's going to be presenting at the PTA, or will it be?
Me and one of our other members.
Okay. And when is that going to be?
November 1st.
November 1st. That may be something that I'd like to see. That's very interesting. How does what you're doing here relate to the robotics project?
So our project was first to reduce plastic, and then we thought about something that could help us and the school we all go to. So we thought how these water fountains aren't as effective for people just to use reusable water bottles, because they'll much rather use plastic because they don't want to use the water out of school. But if the water fountains we're trying to get, you can't use the regular pusher. It just does your reusable water in. So we think that'll save plastic. We have the math somewhere. It'll save us a lot of money and oil if we stop using plastic water bottles in Littleton Middle School and all the other schools as a whole.
Okay, and in general, if we stop using plastic, that's probably a good thing, or at least reduce the amount of plastics that we use. And the less plastics we use, the less would be in the oceans, landfills, things like that. This is a very, very interesting project. So are you going to map this, how do you map this project, what you're doing, to the actual robotics? Or
our project is for the water,
Yes.
hydrodynamics, and so as I said about how reducing plastic was our main goal. So this is how we map it.
I see. So this is not necessarily a robotics task here. You're doing a task on assessing the quality of the water, doing some research, collecting data, and you're going to present a report. Wow. I'm really impressed. very good. Once again, I'm blown away by what I see at the Littleton Middle School. I've seen just some very spectacular things with the science fairs. This is another branch of science that I'm seeing, and I'm very impressed. And I think you've really selected a great topic. So, well, I'm here at another design meeting, is what it looks like. And what's going on here? Well, let me first. You are?
My name's Elliot. I'm on the Littleton High School robotics team, and I'm mentoring the middle school kids.
I see. So you're serving as a mentor. Very good. And your first name?
My name is Aiden.
Aiden?
My name is Hallie.
Hallie?
My name is Damon.
Damon. Okay, so what's going on here?
So we are working on our project, which is the second half of the robotics program, the FLL game, and the topic is water and how you can help with water or help clean it. And what we decided to do was groundwater contamination, which affects Littleton public wells. And so we decided to work on an aspect where we would talk about groundwater contamination, and so the Zone 1, which is an area around the Littleton public well, and how septic water can get into the well, and that can go into drinking water, which is not good, and it can cause serious health problems, including hepatitis and dysentery.
Dysentery. Yeah. Now, Littleton's water area, I guess, is divided into zones. Is that correct? I forget how many zones there are. Have you, and you said you were working with Zone 1, is that correct?
Which is an area around the well.
Okay.
It's not Zone 1 or Zone 2, it's just it's in general the area around the public well in general. So
I see. So you have a well, and then there's Zone 1 right around the well, and then when you go further away from the well, that's maybe Zone 2, Zone 3, something like that. Yeah. So have you actually done tests on the soil, on the water?
we haven't done tests on the water, but we plan to talk with the Littleton Water Department about groundwater contamination and how it's affecting people and the environment, and it is in fact affecting the environment because of bacteria in the water. And we were hoping to ask the department if what they thought about the issue and how what solutions they have about the issue.
I see. So you're going to be interviewing them effectively, ask them. Neshoba Board of Health is another resource you can just sort of put in your head that, they have a lot to do with, they have an interest in septic systems and also clean water. So what are you doing on your computers now?
So right now we're working on the project portion of the first LEGO League, which, because as Hallie said, there are two parts, the robotics game and the project. So we're coming up with our solution to solve the problem on groundwater contamination, and what we really want to focus on is educating people about Zone 1 and how the septic tanks, if they're too close to the Zone 1, can leak into it and cause bacteria to get into the wells. And so what we want to do is have a video and educate people. One, don't put try to get people to keep when people are building septic systems, to keep it away from the Zone 1, and also to make sure that people who have septic systems don't pour harmful bacteria down their wells, because it could always, or septic tanks or sinks, because it could always leak into the Zone 1. And
I see.
one thing we want to focus on in the video is if we just have a normal video, that could be boring and people might not want to watch it. So what we want to do is entertain people and have it sort of be funny, so that way people will be interested in watching.
Have you ever thought of going to LCTV and doing some work there? You did, right? You know, they would certainly support you in, you know, getting what you're doing up on local cable, things like that. So you're the mentor.
I'm one of the people from the high school team that helps mentor.
I see. So how they doing?
They've been doing pretty well, coming up with their project and setting up their presentation to give at the competition and all that.
Yeah. So, so I can really relate this to business, that you're going through some requirements gathering, you're trying to figure out what you're doing, and you're putting together a project plan, you know, plan of attack, how you're going to approach this. And when are you going to be approaching the Littleton Water Department? Do you know when?
I'm not sure, but I think it's probably going to be in the next, like, 2 weeks or so, maybe.
Next 2 weeks. So you're all going to march down there? And, yeah, right. Right. This is a great project to be doing. I mean, clean water is very, very important to not just Littleton, but life on Earth, really. So this is great. Yeah, I'm going to be very interested to see the results of your research, how it's accepted by the town, and what your next step are. That's very great. Very, very good job.
Thank you.
I'm here with Zach Temple, and Zach, thanks for coming on camera.
Certainly.
Yeah, and what's your role in Littleton Robotics?
So I'm one of the mentors for the team. We've got a bunch of adults who come in, help out. Basically, it boils down to being adult supervision, as well as providing these teams with some help when they need it, and a little bit of guidance. And it's a lot of fun. They really do guide themselves for the most part, and when they need a helping hand, they know who to come to.
Yeah, I'm really impressed with the quality of these kids from an engineering level, and also from their ability to talk, and they're just nice people.
We're impressed with them every time we come to meetings here. It's amazing what putting the right things in front of them and let them go to town with it. They get a lot more done than you might expect.
Yeah. How long have you been doing this?
So I've been doing FIRST overall. This is my 10th year with FIRST. But as a mentor for this team, I mean, this is our first year with Littleton FLL. It only just became a thing this year. But Dee and I have both been mentoring FLL teams for now. This is, I believe, our third or fourth year mentoring FLL teams. And for both of us, it's our 6th year mentoring FIRST teams in general.
I see. And what's your background?
So I started FIRST when I was in high school, and did it as a student the whole time I was in high school. After that, I started mentoring the same team that I was on in high school. Somewhere in there, went to college at WPI, got a degree in mechanical engineering, brought all that to the team as well, got a job working as a mechanical engineer, and doing this every moment I could.
Yeah. WPI is a great school. What type of engineering do you do?
Mechanical engineering is my focus.
Yeah, but for what application? What sort of?
I'm currently working for a government defense contractor.
I see. Yeah. Okay, so don't tell us anything.
I know nothing.
Well, I really have to say, my hat's off to you for volunteering your time to help these kids grow, and I'm sure you're growing as a result of this.
Yeah, and it's we'd be nowhere if it weren't for Dee organizing all of this. It's she keeps our heads all screwed on straight when we can't keep track of anything. It's really great to have a team that's managed so clearly, especially when you get all these excited engineers around who can't keep track of a schedule.
Right, that is a common thread with engineering.
It is.
I know that from my background. So, well, thank you for your time, and thank you for your efforts here. This is really great.
Certainly. Thank you for joining us today.
Thank you. Okay, I'm here now with Brett Bonner, and Brett, good to see you.
Good to see you.
Yeah, and I first met Brett at Third Thursday.
Correct.
Right?
Yes.
And the kids there, actually I met you and your wife, Katie.
Yes, we're both involved with Littleton Robotics.
Yes, and when I was there was a machine that was throwing out balls.
Correct. That's our FRC, our high school robot. I'm a mentor for that team as well as for FLL.
I see. So you're a mentor.
Yes.
And for both the middle school.
Correct.
And
for the high school. So for the high school, I mostly focus on software and electrical for the robot. At the FLL level, we kind of do everything.
I see. So this must take a lot of your time.
It does, but it's a lot of fun.
Yeah.
We enjoy it.
Yeah. The kids must really grow.
It's tremendous, and I've seen the change in my own kids, so that's part of what's encouraged me to continue to be involved.
Yeah. This is as competitive, I would think, as any athletic endeavor.
It absolutely is, particularly when you hit the high school level. The FRC competitions are very intense, very rewarding, but it demands a lot of both the kids and the adults that are involved.
Yeah. What do you think when a team is preparing for a competition? How many hours do they invest in that?
Well, so are you talking about FLL or FRC at this point?
Well, I'm not sure. You tell me.
So FLL, we try to keep it pretty manageable. Our normal meeting schedule is 2 evenings a week, and then we add some weekend meets and occasional extra evenings as we get closer to competitions.
Okay. Do you think the kids are working at home, thinking about things? Because what I'm seeing here, talking to the kids, is a level of excitement, and I doubt they can just go home and drop it.
Right, we hope that they don't. Certainly for FLL, we expect them to do some of the project work in particular when they're on their own, and they do get homework that we expect them to do research or things like that towards that end. Obviously, they don't have their robots at home, but they can still be thinking about mechanisms, thinking about the problems they're having and how they can solve them and things like that.
Yeah. I find this very interesting how this is divided up between the robotics and the project-oriented work. That seems to make a lot of sense.
Right. So that's one of the differences between FLL and FRC, actually, is the project component is a big part of FLL. It's really half of what the teams are doing. At the FRC level, you don't have the project aspect, but there's a tremendous amount of outreach that's expected of teams, and that sort of takes the place.
I see. Well, I want to commend you for, investing your time in this and, with the kids. I mean, the growth and the excitement is
Well, I have a lot of fun doing it.
Really apparent. So thank you very much.
Thank you.
Okay. Well, this concludes another edition of Fun with Science, and I'm here at the Littleton Robotics. This has been very interesting. I hope you found it enjoyable. I know I certainly did, and I continue to be impressed with the quality of students and that we have in Littleton. And later on this year, we'll do something with the high school. These kids we were talking to, these are middle school kids. I'm very impressed. So I hope you enjoyed it, and we'll see you next time on Fun with Science.